Lesson 95, Graphs of Nonlinear Functions and Recognizing the Shapes of Various Nonlinear Functions. Okay, up until now, we have done functions that were linear, meaning they were straight lines. And those functions look something like f of x equals mx plus b. So what does this tell you? F of x is your y value. So whenever you would have an axis like this, this was the function of x. So whatever number you subbed in for x, the function of x was the y value for that x. Okay, so now that we understand that this just means y, it's just the name of the line that we use. This is the F line, or the G line, or the H line, or the A line, or the B line. That's all that is. This is your y values. So the function of x equals mx plus b. That's your y intercept, or your slope format, and that is a linear function. And a linear function is just in a straight line. That's what the definition is, an adjective that means in a straight line. Okay? So with a linear function, you would see a line that looks like this. And that is supposed to be straight. It's not really, but you get the idea. So that is what we're looking at. We're in a straight line, a linear function. Okay? All right. Now we're going to look at some non-linear functions. And I think we probably ought to move to the graph paper for this. And I'm going to, let's make that a little bit bigger. There we go. That's good. All right. So let's start with quadratic functions. So quadratic. And we're going to talk a lot about these later on. But quadratic functions look like this. Your y values, that's y, is going to equal something like ax squared plus bx plus c. So you have an a value, a b value, and a c value, right? And that is where a is not equal to 0. Okay? And a quadratic function makes a shape on a graph that looks like this. Let me get a graph here. And that shape looks like a U. And one side is the mirror image of the other side. When you actually can draw it out on a real graph paper and get a real shape. So this is what a quadratic function looks like, and we call that shape a parabola. Okay? So all we're doing in this lesson is learning the formulas for the quadratic or for whatever type we're doing, and we're learning to recognize the shape of that particular type of function and what that shape is called, if it has a special name. All right, so now let's look at another one. And this is called a cubic function. And a cubic function is a function of the form f of x, that's your y value, and that equals ax cubed, right, plus bx squared plus cx plus d. So this is your cubic. And obviously it's cubic because you have a x value to the cube exponent. so x to the cube root, gives you the cubic function. And on a graph, it is going to look like this. Let me get a graph here. And it has kind of a weird shape. It is going to have an intercept somewhere, anywhere, and then it is going to make a little curve up, and it's going to have a mirror image, but it's going to be curved down. So with the quadratic, these curves go the same direction, just on the opposite side. With a cubic, it has the curve, but it flips down. One side will flip down. So that is a cubic shape, is when you have this. Okay? All right, be sure to take these notes because you're going to have some problems that ask you to identify the type of function. And you're going to have to say whether it's a quadratic or a cubic or a linear or whatever the type might be. So please take these notes down and take these formulas down. Those are going to be important. All right, I'm going to clear the page and we're going to go through some more. We have a couple more. So now we have what's called a square root. And we all know what a square root is. We know we are going to have to deal with some radicals with this formula. So the function of a square root is going to be a radical over x. Okay, that is a square root function. And we typically figure these out by graphing the points of this. That's just the way we do it. So a square root function, let me draw the graph for you. And remember that f of x is just your y value. That's your y value. So the y value is the square root of x. Whatever x is, the square root of that is your y value. And so that looks something like this. You'll have a point that is a definite starting place, and then it is going to curve up and over. That is a square root graph. And you'll have points all along the way. So that's what that is. All right, that's a square root. Let's do, I think there's one more. There is. Now you have an absolute value function. We know what absolute value is, right? Absolute value. And it makes perfect sense when you think about it. That is where the function f of x equals the absolute value of x. So your y value is the absolute value of x. So that means that if x is -1, then y is 1. If x is 1, y is 1. If x is -2, y is 2. If x is 2, y is 2. So that means that your graph is going to look like this. It's going to start somewhere, and then it's going to shoot upward at some slope and have an identical slope in the flipped. It's a straight line on both, but it's flipped. The one's going to go the opposite direction. Okay, that is the absolute value function. And that's it for lesson 95. That is all we are doing, is identifying the shapes of these types of functions. And you should be able to memorize those. So you should know what a quadratic function is, and that shape is a parabola. You should know that a cubic function is when you have one side of the parabola flipped downwards. You should know that a square root function is just half of a parabola, and that the absolute value function is a v. If you can remember that, then you'll be doing great. All right, so I will see you in lesson 96.